Yeah, so we are starting today's meeting, and we're just going to briefly go over real quick how to get into the iLab so that we can continue on into the activities that we have planned today. And we'll be going over completely the first challenge for the 2020 FlareOn challenges. If you need more information for that, all the links have been sent in the previous emails, and they're posted in Slack as well. But then we'll also give a couple of hints for the second challenge, just to keep people going on the 2020 FlareOn challenges. And then after that, we'll also cover doing network analysis and how that pertains to identifying malicious activity, within PCAPs. And we'll be using WireShark for that. And I'll show where you can find more of those exercises as well if you decide you want to practice this in your free time. So we'll start off by going to the ilab.dsu.edu. And if you don't immediately have that, I can drop that in the chat if I can find where my chat box went. There you go. Cool. So from there, once you get to this page, you'll just go to the projects cluster, and you'll have to log in using your DSU username. So for me, I'm Micah A Flack, so it's MA Flack. So use that, your password, and you'll get to this. You'll click the project's default, and you should be presented with this screen here. What you want to do is you want to go Actions, and then power on your Flare VM. If you don't have this, shoot me an email or a message in the chat, and I can try to get that rolled out to you soon. Just hit power on. It'll take a minute to start if you haven't already.
Can you tell them about the VM remote console option?
Yeah. So what I do is I have a remote desktop client that I use from within the VM. I can kind of show a better idea of it once we get loaded in. And if you don't remember the password from last time, it is capital P password 1 exclamation mark. And I'll put that in the chat as well. But if you like to have a bigger screen than this, there's a couple of options. Just to kind of get this out of the way real quick. You can either download the VM remote console, this button, and it'll take you to this page. You can download it, if you're on Windows, Mac, or Linux. You'll have to make an account and sign in with it. For me, that's just there. And then it'll start downloading as a zip. You unpack the zip, and there's an executable that you can use to install the client. So that's one way you can do it without having to use the web console. And one reason you might want to do that is because if you use the VM remote console, you can copy and paste things inside and out. You can also stretch your screen a little bigger, so you're not limited to just this square screen. So just let that load real quick.
And even if you are in the web console, you can also just go into the display settings and change it there as well.
True. Yeah, so that would be display settings. And you can go under here and you can kind of tweak it a little. So for some people, depending what kind of screen you're using, you might just want to go up to like that much, 1366 by 768. It's common resolution for some screens. But also, just so you know, I don't believe these VMs in the iLab have a large amount of dedicated VRAM. So if you make your display too big and then you start dragging a lot of windows across it, you're going to lag it out. So you just have to keep that in mind. Not that I imagine everybody's running around with a 4K screen and they want the VM to be able to support that. That was a good point too. You can also go in here and you can, if you have the VM RC installed, you can click Launch Remote Console. You just allow that app association to open it. It'll just take a minute. And then this one's a little nicer because it'll automatically scale as you drag it. So you wouldn't have to go in and right click and set whatever you want it to do. You can even full screen, it'll automatically do that. What I use is a little different. Well, before I get into that though, something you'll have to keep in mind if you're doing like a really long activity, or maybe you're using this for a class or a personal project, and this is your first time using the iLab, you have to keep in mind your release time. If you're expecting something to just run in the background and like you're doing a volatility memory recovery or forensics of some kind, and you're analyzing a large memory dump or a binary, it's going to take a lot of time to do that. And sometimes, if it takes you like a couple hours to get set up, and then the analysis is going to take another 5 hours, your lease is going to run out, real soon, and it won't finish. So you just have to keep in mind to routinely click this renew lease button, and it'll bump it back up to the maximum 5 hour lease, and you don't have to worry about it for another 4 or 5 hours. That's just something to keep in mind, because I know I've been burned by that with homework assignments, and I didn't, I wasn't mindful of it. Not that I would expect anyone to be using this for homework. Oops. Oh, my screen's a little messed up. 1 second. I'm going to change the screen that I'm sharing. Nope. There you go. Cool. So can you guys see that all right? You should be able to see my desktop. We'll just go straight into talking about the 2020 FlareOn challenges. So we briefly covered at the last meeting one of the initial challenges for the 2014 FlareOn challenges, but this time we're going to go over the 2020 challenges, and these were released September 14th, I believe. So they've been out for a couple weeks now. You can actually look at the scoreboard and you can see how quickly it took some people. So it's actually top of the scoreboard from Georgia Institute of Technology, South Korea, score 11. So they did all 11 challenges, and it only took them 1 day, 23 hours, and 34 minutes. And you can see their affiliation. So it's pretty interesting. But you go back to the challenges. If you just want the challenges and you don't necessarily want to have to create a profile and go through everything, what you can do is you can just go to, well, that probably wasn't immediately clear to anyone, but drive.malware.club. This is the drive folder that is shared with everyone, within the malware club. So you just go there, it'll take you to this drive folder, and we're going to be coming back here for the network challenges, but you'll just go under FlareOn 2020, and you'll want to download both of these. You can either do it one by one. You can select both of them. You just go download. And it should zip both of them, and you'll have to go to your downloads and unzip it.
Can you tell them where to go for Captive Portal if they're not sure?
Oh, yeah, my bad. So if you're having Captive Portal issues, you should be able to, well, for me, I bookmarked it after I sent you all your VMs, so that's my bad. But if you hit the Windows key and you search Edge, it should bring this up. And it's just going to be another window like what I have here. But you should just be able to type in the URL bar, Captive Portal, and this entry right here with the PHP uid.php ?vsys. This should be cached in there. You just click that, and it'll take you to here. So you just use your D2L username, or it's the same as your iLab credentials, actually. I should say that. So it's your user for the iLab, and then your password for the iLab. And you'll click login, and that'll authorize you, to have network access through the iLab in your VM. Is everyone connected? Do you all have network access? You can all you can raise your hand or just put like an OK in the chat. Just want to make sure we're all on the same page.
Or if you need him to slow down, you could just say slow down. Or
yeah, that too. I do go a little fast sometimes.
Well, I mean, I don't think you're going fast, but I mean, if they're having technical issues or something.
Oh, true. Oh, okay. Yeah, they should get back to you fairly soonish. Others, I think that's everyone because Harrison was traveling. So once you're through the Captive Portal and you've downloaded those files, you can just go show in folder or just directly under your downloads. And you can just go 7-zip and extract to drive download. You'll get this folder and you'll have challenge 1, which is a solution that I've provided as we go through the first challenge. And then this second zip folder is 1 through 4 of the initial challenges that you'll find on the Flare 2020 site that we were just looking at. Which is another set of zipped files. So for each of these, you'll have to use the password Flare. And I can put that in the chat as well if you can't really see it on my screen. And you click OK. And that should unpack all of them. And sometimes you want to keep these zip files and not delete them immediately, because if you get something like a executable file and you tweak things within it, like you make changes to the import table, the image base, address of entry point, anything like that, you'd have to go back to FlareOn, download the zip, unpack it, you know. Whereas this way, if you mess it up, you can just go here, right click, 7-zip, and extract with the password. And you just say yes to all, and that should overwrite everything. That's just a little tip. But to get started with this first challenge, you'll just go 1 fiddler, and you have 2 options. Well, first, actually, we should probably read the challenge message. So they're just saying, welcome to the 7th FlareOn challenges. This is a simple game, win it by any means necessary, and the victory screen will reveal the flag. Enter the flag here on the site to score and move on to the next level. This challenge is written in Python and is distributed as a runnable exe. It's a Pygame exe, and as matching source code for your convenience. You can run the source code directly on any Python platform with Pygame if you would prefer as well. So you can keep that open if you want to refer back to it. But you can see what it means just by clicking this fiddler.exe. You just double tap it, and you'll see a Pygame window open. And this is the fiddler.exe program. You can just kind of mess around with it, type in, see what it does, and you'll be provided with this screen. You know, you done goofed, don't pirate this game. So what you have to do then to get the flag is either there are several ways you could solve this. We could probably take up the entire meeting going over ways to solve this. You could fuzz it, you could put the program through a debugger and you could step through it that way. Or what you could do, which we're going to go over, is you're just going to go through the source code, rip out the relevant code, and then you're going to run it in the Python IDE, and you should be able to retrieve the flag that way. So we'll just close that. That window will close. So just go here, right click on it, say open with. You're probably going to want to use something like Visual Studio Code. That should be on everybody's VM. If it isn't, let me know. And you might have to click this box to install the recommended Python extension. But that doesn't break anything, so it just takes a second to load. So once that's installed, you can click this Tetris-looking icon, and that'll put the extension window away. And then you also have to click the linter pylint install. That just goes through and it essentially proofreads the code. And this also takes a quick minute.
How do you get the second install?
The second install, so after you've installed the Python extension, which comes up immediately when you open a Python file in VS Code, so I can kind of go over it. You'll right-click Fiddler, you go open with Visual Studio Code. When this window opens, and if you're opening a Python file for the first time, you'll get a window in the bottom right that says Install Extension for Python. Once that one has installed, you'll get another window in the bottom right, same location, asking you to install the Python linter. And this is just what you need to do some general proofreading and making sure that your code's syntactically correct. And that's what you saw with the output window here, where it was running just the running console output showing
Looks
that it
like
was
Neil's
installing.
having errors, and looks like mine is having errors too with the linter.
Oh, okay. Do you know what the error is? It could be an issue with pip.
You want me to share my screen?
Yeah, sure. I can stop sharing.
Since I'm having this problem, then wait.
Yeah, everyone else might be having it too.
Sorry, I got distracted there for a second.
No, it's fine. Okay, there you go. I minimized my controls so I can see it. Okay, I think,
SSL issue there.
yeah. Are you having internet connection issues?
I don't think so. Is this what Neil's having too? Same issue? Thoughts or no thoughts?
Sorry, I'm trying to get to my chat windows. Yeah, I've never had this issue before. Matching distribution. What happens if you type pip and you just hit enter? Okay. Can you go up arrow and twice and just try to run the initial command again?
This one?
Down one. Yeah, that one. Here, let me.
Certificate is not able to verify for whatever reason. Cannot fetch. Do we need the linter for what you're?
No, you don't need it. It's just handy because if you like misspell variables, it'll tell you and whatnot. We don't necessarily need it. Excuse me. We don't need it though.
Okay, I'll give it back to you then. And something like this would probably take a little while to troubleshoot. So
Yeah. Yeah. Sorry. No, it's just kind of confusing because everyone had the same.
well, you have a different environment because you're not in the IA lab, so and you've already done it.
Oh no, I'm in the iLab. I'm in the same
Okay.
cluster. I just connect to it differently. Okay. Yeah. I was just looking at a Stack Overflow post with a potential solution. I'll go back to resuming the demo, but if you guys want, you could try that.
Okay.
Okay. Yeah.
We can't see your screen if you're sharing it.
Oh, I just switched. Okay. Yes. Sorry that the linter is not working. I can just go over it all from here, and then we can maybe try to fix it afterwards. So can you guys all read this okay?
Yep.
Okay. So this is the fiddler.py script that they provide. It's essentially the source code for fiddler.exe. It's written in Python 3.7, I believe. Although it's not necessarily important. Anything that's 3.6 and up is essentially the same thing, minus some very small differences between libraries, which I found out during my internship. But to kind of just get through the weeds on this, it's kind of the same thing or similar problem that we had with the first challenges that we went over when looking through the .NET code. You kind of have a lot of garbage, so to speak, with just looking at how it draws the screen and the different text. This isn't initially important, and the key thing to think about whenever you're doing any sort of quote unquote high level RE with interpreted languages like Python, you just kind of have to go with the flow and see where it starts. So typically like with the main function here, and then just step through it and try to reproduce what you're seeing when you actually run the program. So you can see here we have main. We're going to go up to the password screen. And if that is true, then we're going to go to the game screen, which would produce a victory. If this is false, then we're going to produce the fail screen, which was the you done goofed, don't pirate screen. So what we want is we want to step through it so that we get the victory screen with whatever sequence it needs. So what we'll do is we'll go back up to the top to the password screen, and you'll see here we're just pretty much drawing that window that you saw, the clock, the heading text, the prompt for the password we were going to enter. You get an input box, some controls, making the input box active. None of this is really important. And then you get, sorry, I need to move my cat. And then you'll get down to this while loop, and you'll see that while not done, and this while not done is the password submission. You get a for event with a typing into the input box, and then a control. And then you also get the input box dot submitted. So this is where if you fill into the input box, it's then going to go to the password check. Password check, you're going to immediately think, okay, so it's passing our input, the text from the input box to this function. So the next thing you're going to want to do then is go down to, or up, I guess, to the password check function here. You'll see it takes an input with the altered key, and it's going to produce some, supposedly obfuscated or deobfuscated text that's going to compare against here, because this isn't the actual text that's comparing against for your password. It's taking this and it's going for a join for each character in altered X. That's a character, and it has been shifted by -1. So what you can do is to figure out what it's saying, you can just straight up copy that. And what you'll do is you'll go Python IDE. Oh, I spelled it wrong. well, there's another shortcut. You just go open with Python. Wrong Python. It has to be the Python IDE. So I keep opening the wrong one. Choose another app. My bad. So you click the Windows key, make sure you type Python correctly, and it should be the first one that pops up. It's the IDLE. You should see the screen, and then you'll want to go, if I remember correctly, new file. Yep. And you can just drop this in here. Make sure you remove the tabs so that the code, is syntactically correct. And what you can do is you can just change this to print key. And what this will do is it'll essentially just print out whatever the password is that you are comparing against. Because you're submitting password, it's going to compare that input, and this is the key it's comparing to get past the password check, which is the first stage of the challenge. So what you'll do is you just go run. Oh, you have to save it first, and you can just kind of dump this into your fiddler folder. Just say like test.py, save, and you get this text here. So ghost. So to verify that, you're just going to run the program again. It'll get to the password stage, and you can just go ghost. And voila, you're at the next stage. And you can verify this flow of the program by going from here, seeing that it's password check. So it's going to return true. So you have to go back to where password screen was called, which if you recall was, if I get to it, down here. So it's returning true. We're then going to go to the game screen, and then you go up to the game screen function, which is right here. And this is drawing, this is everything to just draw the weird game screen image you saw with the cat and then the coins. And some of this functionality might make more sense just reading this prompt. So if you click on a kitty to send her out to catch mice or earn money, if you earn about 100 billion coins to win, it will reveal the flag. So you can just click on this and you can see the coins go up. If you get 10 coins, you can buy an auto clicker, and every second or so, it'll buy one. And if you get really bored, you could just keep doing this and keep buying auto clickers. But you don't want to do that. Because if you can already see with just like 11 auto clickers, you're at a pretty slow pace to catch up to 100 billion coins. And you might think that it's being sarcastic about that threshold. It's not. And you'll see this. So you go through here, you'll see that it's just drawing the screen. You've got your labels for the text, the kitty image, buttons, just different parts of the window with the text, the color, the buttons, the box. None of this is really important. Where it gets to the part that you need is, again, where it gets to the while loop, where you see more flow control. You see some arbitrary value here, which is target amount equals 2 to the power of 36 plus 2 to the power of 35. And a lot of these challenges, they're really just like convoluted math or cryptography, and you'll actually see this a lot with malware, where sometimes, again, they're just trying to confuse you, or they're trying to make it harder to figure out what it is exactly that they're doing. Might not seem like that's the immediately their objective here, seeing as you're playing with kitten, trying to get more coins. But that's generally the goal. So what you'll need to do to figure out what it is that that value is counting up to, you can just go oops, gotta switch to scientific. Just go 2 to the power of 36 plus 2 to the power of 35. And there you go. There's your 103 billion coins, which is slightly off. So you just follow this down. So you copy that. So you get that, and then it's going to go by the current coins. The current coins are however many coins you have at the moment. And to get to this next portion, and it's this if statement you want to get to, because you'll see this victory coin, or sorry, victory screen function. And you'll see that the victory screen function, if you go down, is here. It gets token value. And then the token value, you see more just garbage code. That's just for drawing the screen. And you'll see this function here, decode flag and token. So the same token that it gets here for the victory screen is the token that it passes to the decode flag function. And you'll see here decode flag, frob, and a whole lot of nonsense. And the only way you're going to decode this is if you get that token value. So you have to step all the way back up and into this function here for the game screen. And you have to figure out all this math. And we'll show just how to do that. So it only triggers here if the current coins is greater than the target amount minus 2. Oh, my bad. Minus 2 to the power of 20. So you get this value. It's not really a big difference, but it does affect the end value that we're going to get when we're generating our token value, which you can see here is just the current coins divided by 10 to the power of 8. So next thing you can assume is, oh, I jumped the gun there. So this is just saying that if current coins hits that threshold, then we're going to step down. While current coins is greater than or equal to target amount plus 220, which is just going to be the above amount added to what it was. So you'll actually just drop down and you're going to get this. So the current coins is going to be equal to that value. So what you can do is you just go divided by 10 to the power of 8, and you get 103, or sorry, not 103, 1030.7. But this is an integer, so, well, really, if you don't even want to bother with it being an integer, you can just go here, and you'll do that. And what this would do then, if you were to copy this, and we're actually going to do the same thing again with the idler, and this is a pretty common thing where you're just going back and forth between the obfuscated code and then trying to find the end result. So you got to tab it back. And you can just change that to like a print. my bad. So instead of actually doing all the math by hand, another thing you could have done, which would be a lot quicker, is to... Oh. Are you guys having connection issues? Oh, never mind. I'm back. Yeah, so you put that back to the original function with int around the current coins divided by 10 to the power of 8. And you have to change really just copying this line, because you need to have current coins at some like arbitrary value. You can just set it to the target amount. You'll go run, save, and what do you know? You get 1030. So that's the token that we're getting when we call the victory screen. So you go from the victory screen and you go down to this function. You get more garbage code. And you remember we have the decode flag function. So the decode flag, you go up to this function and you copy it. Actually, you can just go copy the entire function. You go to the test.py, paste it, and then you just go a line or two down. My bad. You say print decode flag 1030, because that was the token value that we got from going through the game screen. And you'll just hit run module. Okay. And there you go. There's your decoded flag. And if you're on the FlareOn site, you could just copy this and you go to FlareOn. And assuming you're already logged in, you can see what the screen looks like. If you're logged out, you'll see this screen. It's my bad, I did not share this initially. Oh, okay, there you go. Didn't see that you won it by playing.
Yeah, I just keep buying in powers of 10 and it goes pretty quick.
Okay, yeah, you can do that too. Brute force is always an option. But if you want to submit the flag, and get your reward, you go to that link, you register, or if you already have an account, log in, submit. You scroll down and you'll see this one right here, FlareOn, first challenge, Fiddler. You click this and you just paste your actual flag, not the link. Wrong window. So you just copy that, you go here, you drop it, and submit. And if you haven't already solved it, it'll say that you solved it. I did it in preparation for the video, or for the meeting. So that is how you do the first challenge, and that's just, for the most part, debugging Python code. Does anyone have any questions for it? It's one of the more straightforward challenges.
Nice job.
Yeah. If you really like this challenge, you should definitely keep going. I'll briefly go over the second challenge, garbage, and then I'll try to quickly just get through our network analysis portion of the activity for the day, so I don't hold on to everybody for too long. But for the second challenge, if you can't read it, I'll read it out loud. It's one of our team members developed a FlareOn challenge, but accidentally deleted it. We recovered it using extreme digital forensic techniques, but it seems to be corrupted. We would fix it, but we are too busy solving today's most important information security threats affecting our global economy. You should be able to get it working again, reverse engineer it, and acquire the flag. So same deal, you download the zip. Once you get the flag, you submit it here. But we already should have the files. So you go to the second garbage folder, and you'll see that, executable. Again, my recommendations for this, like with the last executable challenge we had, you're going to go through your utilities, and you want to identify what the executable is. So you just drag the garbage over into exe info, and this will give you all sorts of information. Like it lists the first entry point section, which is the UPX1. If you're familiar with malware analysis or even software, because packing is a legitimate obfuscation method for software developers. But you'll see things like the entry point, file offset, file size, and the EP section. And you also see this identifier down here, which indicates that it has identified a signature for the file of the UPX packer from Marcus and Laszlo, version 3.94. And then you also have a overlay of nothing. And these are two very important parts of solving the puzzle. Another portion of it is this sections viewer. And if you want to repair this executable, there's several things you're going to have to do. You're going to have to fix the import table, the export table, and the entry point to be able to get the program to run. And you'll be able to see what I mean by this, because if you were to use your typical first step, once you've identified that something's been packed, the first thing you want to do is unpack it. Stretch out this window a little. I can't zoom in. Let's see if I can make the font a little bigger. There you go. So again, the first thing you want to try and do is UPX, which is the same program that was used to pack it. Like you're using 7-zip or RAR, you want to unpack it. So you do -D for decompress, and then you say the executable. But you'll see that this is an indicator of what they're saying, where you have to repair the file. You have an overlay exception and invalid overlay size. This is going to be one of your first indicators for the steps that you have to take to fix or repair it. If you want any further guidance, you'll want to look through this article here, which I will put in the chat. If you, for some reason, you can't see clearly if you pause the video and you're trying to get to this article, I can put it in Slack as well for everyone, or I can push it out through email. But
do you
that
give
is
the name of what the link is, like the dealing with UPX packed executables? Somebody could just type that in the Google.
You want me to put it into?
Well, I mean, I guess I said it, but I was just saying if you just type in dealing with UPX packed executables, you'll probably find it.
Yeah, my bad. Sorry. Yeah. So, like Bramwell said, if you just search for this title, dealing with UPX packed executables, you should be able to find the article that way as well. But it covers everything from, like we just did, identifying packed executables, and then also the different manual and automated methods you can use to unpack them. In this case, because the file has been damaged, so to speak, from being deleted, you have to fix several fields and address points or offsets within, and tables, I suppose, within the executable to be able to unpack it and finish the reverse engineering process. So again, this article, it'll go over doing the automated method and then also the manual method using OllyDB or DBG or OllyDebug. And just one more hint before we go into the networking activity. A significant portion of this can be done automated, which is repairing the import and export tables using a program called, they mention it here, PE Explorer. This doesn't come with FlareVM, mostly because you only get a 30-day trial to use it. But it's fairly handy because rather than having to use something like PE file, Python program for examining PE structures, or a tool like O10, which is a hex editor, and then using a exe template, you can use PE Explorer. It'll analyze the file and then it'll repair the import table for you. If you're a little loose on that and what that all means, if you have some background with assembly, you could read this MSDN article, which goes over the PE file structure, and it actually, it's a wealth of information.
Could you just say briefly what imports are?
Yeah, so the imports, typically, so you have an executable file, and there are certain functions that are included or needed from outside that executable, and they can take the form of DLLs, or dynamically linked lists. These DLLs, they can contain functions that the program needs for the core functionality of it. So let me see if I can find maybe one instance on here. Well, I guess a common import or a common DLL that you'll see is the like addvapi 32.dll. That's just a common one that you usually see if you're doing any sort of analysis. But then within that DLL, there are functions that could be like get file pointer. These functions are the same ones that you would use like with printf when you call it within the program. It links those functions within the DLLs. And there are entire tables within the PE structure, like the see if I can find it. If you had something you want to say, you can say it too while I find the section I was looking for.
I think that's a good description of what that is, an API. So it's just a way to bundle up functionality inside a DLL and make it available to executables.
Yeah, thank you. That's a little more rounded explanation. Yeah, I guess I don't know if it's on this one section. There's usually I think I actually have the wrong MSDN article here, but the one that I was trying to show, it explains things like right here, the MS-DOS stub, the file header, optional header, and then it goes into describing the import file table and what exactly that means, and like how you can find the things like the hints, the names, and the ordinals.
And the IAT is in one of the data directories.
Yeah, exactly.
With this IIT, like what he said can get damaged, and so you got to repair it.
Right. So yeah. So under here, you have under the file header section for the MSDN article. You'll see optional header data directories. This is a section within the PE structure that contains information like the export table and import table. You'll find that information within the eData section or the iData section. It can also be hidden or blown away. So what you'll need to do is recover the IAT, which is the import address table. And you can read more about that here. And it explains the offsets that you need. So if you were to work your way from the top of the PE file, you would start off in the MS-DOS stub, and then you would go through the file headers. So through the offsets, you'd make your way to the file header, optional header, and then down through the data directories. And you have a entry point, as well as the base of code or image base that would tell you the offset that you need to use to be able to get to the image directory table. Sorry, not image, import directory table, which all can be kind of confusing at first, especially if you're doing this for the first time. So this might be a harder challenge for new people, especially with it being the second challenge right off the bat. But for people who've already had the malware analysis and reverse engineering classes, it should be fairly straightforward. Cool. So,
and the import table is the IAT is down below the import address table.
Yeah, right. So it's right here. And you can click that, and you'll be able to read more about it there. But between this MSDN article and the one that we just included in the chat, dealing with UPX packed executables, it covers a large part. Oops, my bad. Of how to compare the structure of the garbage exe and the different sections that you might need to repair. So cool. So now the second portion of this activity that I had planned, or maybe second or third, was to go through a traffic analysis exercise provided by Malware Traffic Analysis. This is a pretty decent website that's still maintained, as you can see by their technical blog posts, which go all the way back from 2013 up to now in 2020. You can even just click on this and you'll see they cover everything, like the latest Emotet infection with TrickBot, Drydex, more Drydex, more BotBot, or maybe like LokiBot. So if you want to read about these, you can. But for today, we were going to go over the traffic analysis exercises. And the one I picked because it just sounds funny was OK Boomer. And you can either download the associated files we're using for this exercise here on his website, or you can also get it from the Drive folder. So Malware Club Network Challenges, OK Boomer. And if we do more of these, they'll be under here. So we'll have them in multiple places just to make it a little easier for people to find. I know we're running kind of later into our meeting, so if everybody doesn't have the free time to continue, I understand that. We can pick this up at the next meeting, or we can continue if everyone has the free time.
Do you want to take a vote or just continue and let people drop off if they want to?
Okay.
Neil is 40 minutes.
Cool. Well, I'll give the express version of the exercise. Should go fairly quick. I think, have you guys all taken your networking classes with Telus? You can still get through this without having, taken those classes, but it definitely helps, especially because, he explains everything using WireShark. Okay. Yeah. This should go okay then. So once you have those files downloaded, you can read more about the scenario here, which explains really the context of what you're looking at within that PCAP. And a PCAP, if you don't know, is a network capture of network traffic. You can read that PCAP within not just WireShark, but you can also use things like EtherCap, T-Shark, or other third-party provided services like Packet Total. And you can go to that if you're curious. This one's really cool because it does a lot more and a lot less than WireShark does. You can still look at the individual packets and you can see the different statistics for them, but it's not quite as thorough and low level in the same sense. Whereas with Packet Total, it has other built-in services into it for analyzing those network traffic captures, or PCAPs. It has Suricata and Snort, and those are two services that use both static and dynamic or behavioral signatures. Behavioral, they indicate things like if it has this hash or if it's this file type and it's making these connections to this server, or it's trying to upload these files, or this payload contains this set of strings or hex bytes, then it identifies that executable or sample, or I should say packet specifically, within the network traffic, to that signature. You can explain a little bit more of it after we do the WireShark. We'll upload it here and we'll show a little more why you might use something like this versus something like WireShark. So again, you have your scenario here, the segment range, the domain controller, the gateway, as well as the broadcast address. So just to make it a little easier, the reason why we're using this exercise is, one, because they provide the network traffic capture, as well as several quick questions that we can just run through. Just having the objective makes it a lot easier to stay on task and figure out what exactly we're doing. So what I'll do is I'll put this over here so we can see our tasks. Close that, close Fiddler. You don't need any of this Python stuff anymore unless you're still working on it. And what you want to do is you want to go to the downloads, where you would have downloaded the zip. You should have a PCAP, or the PCAP folder is what it's called, but you'll have the PCAP folder within it. You can just double click it. It'll open WireShark, and some of you will be familiar with this, some of you won't. It just provides a timeline with metadata for each individual packet, and then shows you the encapsulation for those packets. You can break them down from the frame to the Ethernet to IPv4, or wrapper to UDP down to the payload with the DNS query. But what we're going to do is working for this first initial task, and I'll just kind of zoom in on it. So the initial task that we have is to identify the operating system and type of the device. The way that we're going to go about this is first we're going to search for that IP address. So you'll do ip.adder EQ or EQ, or you could also do double equals instead of EQ. But EQ is just short for equal, and you'll do 10.11.11.94. And you can hit enter. And you'll see we get a lot of different packets varying from DNS queries and responses, NBNS, to different things like, again, TCP, HTTP, UDP packets, TLS. What we want to do is we kind of want to thin this down and narrow it even more. And there's a neat trick. So if you've ever used a browser and you've had to mess around with the user agents, you'll know that typically the way that a lot of developers respond to who's viewing their content is with the user agent provided with that browser. And we can use that to further identify who, let's say, the victim might be, or who the attacker is. So what we'll do is we'll say and then we'll do HTTP. So this narrows it down not only to just the source or destination IP address of 10.11.11.94, but also specifically to the HTTP protocol. And you'll see here, I'll pack all this back up. So you'll see here we have like an HTTP packet. You want to make sure it's from the source and not from the server. So the server being from this 216 address to the 10.11 address, but you want it to be from the 10.11 to the server. So you want to make sure the source is the device in question. And you just hit the HTTP header here within the packet, and you'll get the GET response, expert info, and I clicked on the wrong one. Oops. Is it? Okay, it's here. So you have to go down to the next one because the user agent is missing. But so the question here was, so what's the operating system and type of the device on this address? And again, if you look at the user agent, you'll see here we have CROS x8664 and then a version number. So this device is running Chrome OS. That's 64-bit and then the version number. So then for the next one, we just do the same thing. We just go switch 94 to 121 and go to the next HTTP GET request here with the source address being the .121. And you'll see here again, in the user agent, we have a Android 9 user with a Samsung SM N95OU phone. So the next question we have is, based on the MAC address for 10.11.11.145, who is the manufacturer or vendor of this device? And that is another one that we can do with just MAC. Oh no, my bad. I read that wrong. IP.adder EQ 10.11.11.145. And again, just to narrow it down, it's kind of a cheap trick, but you just say, oops. Yeah, so it's no longer a cheap trick if the device in question has no HTTP traffic on it. So I forgot that. So if you go back down to just the 145 address, you can actually just pull it from this DNS packet by looking at the Ethernet frame of the packet here. And you'll see that it is based off of this destination MAC address. And you can match it up here with the 10.11.11.145 destination IP address, that the MAC address is a Motorola manufacturer. And this kind of helps you just to go through the process of identifying the different like manufacturers or essentially the identities of the devices within this traffic capture. So since we've already kind of covered the operating system questions, we'll just skip to the version of Windows being used. So we'll switch the IP address to .195 instead of the .145. Just hit enter. And I think I froze. So this will just take a second. Oh. Did anyone else lose their connection?
I didn't, but I'm the web-based, so that's a little bit different.
Okay. Sometimes it does just drop. Well, that's weird. Oh, that's odd.
It's kind of hard to see.
Oh, it doesn't want to. Okay. See if we can get it to. Sometimes it doesn't want to change. That's odd.
Maybe try web-based. Or I don't know. Does it give you more choices now that you did that? Oh, it's bigger there, so that's fine.
Yeah, this will have to do, I guess. Reset that. Okay. Sorry about that, guys. So we're looking for the Windows version of the host at 11.195.
Are you able to make that any bigger? Like you were doing like 120% or something. Can you make that 140 or
Um,
I guess you maybe you weren't. That doesn't help at all.
um,
Can you see if you have more options to make the? Why can't you make your screen bigger? I wonder.
oh, there
Oh,
you go.
there you go.
Yeah, I don't know why it prevented it.
Joys of the IA lab.
Mm-hmm. Right. So back to where we were. So we're looking at the 195, and if I remember correctly, there's going to be a specific one. Oh, I froze up again.
There you
Oh,
go.
there you go. Yep. So we'll just do HTTP, and then it should just work again with any request. That you look at the user agent, and again, you can see that it's Windows 64. If you want to maybe get any more specific, what you might have to do is limit it to just the IP address there, and then search for text like Microsoft, where it might be doing like some kind of telephone. Oof. Okay. Okay, I'm back. And typically what you're looking for is maybe something like with Microsoft services, where it's fetching out the Windows version within the TCP packet. Just 1 second. Oh, shoot. Cool. But yeah, so typically you use the user agent within the HTTP field of the request, and you can identify the Windows version that way, as well as if it's 64 or 32. To identify the user account name and as well as the Windows host name for the address at .200, for that you can cancel that and you just search for the 200 again, my bad. What you would have to do is create a custom field, and what that's going to do is look for the field containing the resolved hostname. And you can't actually just use any packet. You actually have to go to the specific one, because to get this portion of the lab, there's a specific process you have to go through with creating the field, and it's better that I just show you it straight from WireShark. And what this is doing is, we're just going to quickly go over this. It's creating a custom field label. And you can kind of see here, like with doing web traffic, by default, you get things like the number, time, source, destination, protocol, and length. But typically, depending on your workload or the kind of investigation you're doing, you might want more context, with your traffic that you're looking at. So some of the things that you can pull out are things like the date and time, source IP and source port, destination IP port, or HTTP host or HTTP server, as well as the info. You can also hide columns, and in the same way that you would remove or add them, it's all just by right-clicking on the columns. So if you go back here over WireShark, you can, let's say, click on source. You can either hide them, or you could remove the source column, or you can also just go up to the column preferences, put this window over here. You could select one, you could remove it that way, or what we want to do is we want to add one. So you're going to hit this little plus square. You would go here, you'd go something like CNAME, and what we need to do is change the type to a custom column, and this should have it in here. Right, so like you see here with the packet doing a DHCP request, you'll get things like the client MAC address as well as things like the host name. And this is what we want to use as a new column. And one way to do that would be if you search for the Kerberos protocol. You can go protocol, and then it's going to be down in the Kerberos header of the payload, or not payload, sorry, the packet. And you should get Kerberos TGS-rep CNAME, CNAME string, and you can see here Brandon.Gilbert. And this is because they're on like a Windows AD network. So if you're doing like maybe forensics to track how like a specific piece of malware was pivoting through a network, and you wanted to see how it was, which users it was using to go between, you could use this network traffic capture, and you would track things like this Kerberos header, and you'd go down and look at the CNAME with the CNAME string. And you can do this, and you can go apply as column, and you'll see here that you get the CNAME string with your packets. So what we would do here, and how that goes back to the question, is you would do Kerberos and IP.adder EQ 10.11.11.200. And you'll see that we got the 10.11 with the Gilbert Windows 7 PC here. And then the user, Brandon.Gilbert. So then the last thing that I think we'll go over, and then we'll show the tidbit of how it relates to packet total, is there is a executable within this network traffic capture. And what we have to do is we have to recover it because this might be the key to the puzzle, and it'll explain how the attacker has been maneuvering around the network and exploiting the given vulnerabilities for the hosts. So a quick way to do this, if you don't have the control bar for Zoom in the way, you would go File, Export Objects, HTTP, and quick way to do it, if you're just going to look for, you want to look for larger, more suspicious files, you just sort by size. You do it the first time, you're going by bottom up, but we want to go top down, so you're going to click it again, and you'll see something like this JS file. You see a .tiff, more JS files, CS file, a JPEG. What you can do while you're looking at this, and you have a lot of large kind of random files that seem out of place, you just click on each one, and then you look at this payload here, and you might see some rather special identifying information. So like if we go here and you hit 40 group, my bad, you have to click the packet number, double click it, and also not have a filter in the way. That's my bad. So with that HTTP object list, you would click the packet, and it'll bring up the relevant packet in question. And then you go down to the file data, and you'll see here you have the file or a payload beginning with the characters MZ or the hex 4D5A, as well as beginning text for a DOS header. So what you're seeing here is that there's an executable, and we have found it. There could be more, but given the size of it, we're pretty sure this is it. So what you would do to go a step further and then analyze this piece of malware that you've recovered is to save it. I already did it, so we're just going to replace it. And then what you would do next is you would either upload it to VirusTotal, or you can use the included CRC SHA tool or hash my files. I'm going to do the hash my files because we can actually copy and paste these hashes. You copy that, and then you could go do somewhere like VirusTotal, and you could upload the sample directly, or you could just search for the hash, which is what we're going to do. And voila, you have identified a malicious piece of software that is being sent across the network. We've identified also as well the source of it is coming from this host here at 188.95.248.71, and it's being sent to the host 10.11.11.203. And the resolved CNAME or host for that is acjabogados.com, 40group.tiff. So that's a pretty big part of analyzing network traffic and identifying those malicious payloads. Now the part that really where you wouldn't need the powerful abilities of WireShark to analyze a sample is you can use packet total, and what you do is you just drag your PCAP over, it uploads it, and it begins a process of vetting the different packets through services like Snort and Suricata. And they'll use their signatures to identify the different parts of the capture that might be suspicious, maybe malicious, any files that they're able to retrieve, specifically, executable files. And then they'll also provide artifacts. So if you wanted to download specific packets from that capture. So this right here is an example of a Suricata alert for malicious activity. And what this means is
Make the
that there were,
font bigger.
oh, yeah. Is that better?
Yeah.
Oops. And I ruined it. 1 second. Okay, so what this means is there were certain parts of the packet that it identified, whether it be, the payload, whether it contained a certain string or a set of hex bytes. It could also just be the sender or the target IP, as well as the port used. It depends on how the signature is built, but what it did was it identified something about that packet, and this is the alert that you see here. Another one here is the PEXE or DLL Windows file download, and this is the one in particular that we were just looking at. You can see here that the resolved hostname or the HTTP hostname was acjab bogados.com with file, and it was in fact identified as an exe. What you could do further is if you're building a report, you could follow this up with a whois lookup. You could geolocate it using the GeoIP with the ASIN, or you could do a search for it for similar results against other packet captures that have been uploaded to Packet Total. And then you'll see here you get more just generic information like with the different connections, DNS, HTTP, Kerberos. So it's much more simple and easier way to maybe just get a quick synopsis of the capture that you've looked at. And it provides more contextualized information because you might not necessarily know what you need to be looking for. But what you're going to be doing is you're going to be relying on somebody else and that they've already figured out what you're trying to find or the problem that you're trying to solve. So it's not necessarily going to be a smoking gun 100% of the time, like you would if you were doing manual analysis and you knew what to look for. It's just, it's a given. Manual versus automatic, you're going to consume a lot more time. But I kind of went a little long on that one. That concludes really what I had planned for today. I'll just mention again what Bramwell had said earlier within the meeting. There's the virus bulletin conference that Bramwell had shared from Josh, and it's going on. It went today, and it's going to be going on tomorrow, right?
Tomorrow and the next day.
Okay, yeah. So you should still have time to register for that if you're interested. There's probably a presentation or a video for everyone. If you don't have the link, just email me again, I guess. It should have been forwarded to everybody who's on the malware club member list. So if you don't have it, you're not on the member list, and you should email me anyway so you can get on it. But that is everything. And thank you, everyone, for letting me chew up nearly 2 hours of your time. I hope it was informative.
I have a quick question. So are most of the students like in or midterms, are getting ready for midterms right now, or?
I think so.
Or
Most
maybe
of
why we don't have as many people today.
Yeah, that definitely might explain it, especially with the meetings being so late.
I don't do midterms, so I don't.
Yeah, all of my classes are just midterm reports on work I'm doing for my projects. So it's a little easier than an exam to study for. I should probably have my chat open.
I don't think we have anything new. Does anybody have anything else that they want to add, or questions, or final thoughts?
Okay. Cool. Then I guess that's it. I'll upload this meeting to YouTube. So if you guys ever want to go over anything again, it's there. And it's also for anyone else who might have missed today's meeting.
I guess maybe one other thing I might add, as far as, I mean, if you want another approach is you can also use Network Miner to very quickly extract everything. I think people have had me in classes and know about that, but if not, then just Google Network Miner. That's just another option.
Yep, that's a good one. Cool. I guess I will stop today's recording then, and I'll upload it as soon as it finishes. Thank you guys for all coming or for watching the video. We'll see you again 2 weeks from now, next Wednesday, or the Wednesday after next, I should say. Thank you guys. Bye-bye.
Bye.